least are comfortable with the material that we've covered so far. And if I asked you to determine what the power of an electronic flash is given the microfarad setting and the voltage, you could tell me what it is, right? Right now you could tell me, without looking at anywhere.
Nope. No.
All right. Not that I'll ask you that. Not that I'll ask you that. But someday, maybe. You have a hint? I think the second part, I don't know what it was. Oh, that's right. Last week I tried to record the presentation on with the Canon, and that only lasted 23 minutes. But only that means that the last part of the first hour was lost, and that one dealt with. I recall it dealt with one fairly interesting statement, or I think I call it pet something, or pet peeve or something. It had to do with how much blur there would be in a subject that's moving. And I think the ultimate conclusion of that little discussion was the fact that you can't really do anything about it in terms of improving sharpness of an image, except by changing the exposure time. Because the ratio between the size of whatever blur you have and the size of your subject is going to be determined at the time that you photograph. At the time during the time that it's exposed, whether the image is small or whether it's big, whether you make it smaller later, detail is a function of exposure time, not what lens you have or what the object distance is. So, and in fact, the best thing to do ever, or all the time, is to photograph the subject as large as you possibly can. Because anytime you have any kind of enlargement, you're magnifying, essentially magnifying noise. So I think that part, and I forget what other part is missing, but if you want to go and reminisce about what last week was like, it's all there. Well, today, I'm not sure that I have enough steam to keep you here for a couple hours, but the idea is to engage in sort of a follow-up to motion recording. So far, as far as essentially hands-on type work, we've dealt with still photography. And when I think about, well, we dealt with still photography, we actually didn't, because you were photographing these dropping balls and the dropping seed and so on. So there was motion involved. But last week, we essentially started on the route of high-speed photography. And but we photographed still images. Oh, by the way, anybody can tell me how their images turned out?
Pretty good.
Pretty good? Yeah. The background was not too obtrusive and so on? Was it okay?
No, not really.
Yeah, good. Are there any pictures on the web anywhere?
I uploaded.
Do you have some? Oh yeah? Can I tag them or whatever?
I can send you a link to them on Flickr.
Yeah, all right. Oh, it's just too bad, because I didn't have a camera. I figure, well, I'll do it next time. I never get to do it. So Well, that's good. But in high-speed photography, eventually there is an interest in going further than the still image, and that is what we're going to be spending quite a bit of time for the rest of the period, for the rest of the quarter, sometime. So I think the next step, start from a still image, is to think about images that are going to be in motion. And while there is an interest, I'm trying to think about how one approaches the subject. How do you first get involved in it? Well, you get involved in it really in two ways. Probably the more popular way is to say, well, I want to photograph something which is invisible because it moves too quickly, and my eye can't recognize it. So you'd call that high-speed photography. On the other hand, there are things also, there's the other approach that people take, some people, the minority take, where they say things are moving too slowly, and I want to see them so that it's interpreted by my brain properly. Because you are in the realm of sort of manipulating time. You're not manipulating time, but you're manipulating the perception of time. And that part, when you're talking about speeding up things that are moving slowly, we call time-lapse photography. Time-lapse photography is something that I almost removed from this quarter, and I said that last year too, because it has gotten to the point where there is very little to talk about in terms of equipment that's available and controls and so on. You Google time-lapse photography, I mean, you're going to see a gazillion examples of people that are doing wonderful work. So you say, okay, well, what's the point? Ultimately, I kind of resigned myself to thinking, well, maybe there is some point to it. To spend a little time introducing the topic of manipulating time and starting out with time-lapse photography. Before I forget, there is, I think I mentioned Harold Edgerton, did I, last week, related to the electronic flash?
Yes.
And Edgerton being kind of the premier guru of high-speed photography in the flash field. Well, there is another person that I want to give credit to for sort of give this person Lifetime Achievement Award. I think I have them right. And you might want to look him up. There is a reference to him on the web. He wrote a neat little book called My Ivory Cellar, which I had 2 copies of, and I lost them both. But he was in the era of what we call analog imaging, film, probably in the 40s and 50s. And he did things in the field of high-speed photography, of time-lapse photography, that even to this day are difficult to do with digital equipment. And he did them with cameras like this one, motion picture camera. So, John out. Unfortunately, late in life, he got involved with ultraviolet photography, and mind went out the window. But the time-lapse work that he did was just fantastic. So I'm thinking about John Ott. Now here was a person who, unlike you, he never went to, I don't think that he even finished high school. he got kind of trapped in high-speed photography, in time-lapse photography, and figured it all out. And so the basis for his work and high-speed photography work as well simply has to do with the relationship between cameras like this one and the projection system. Time manipulation, if you want to call it that, works because there are standards. And in one case, you break the standards. The standards are typically associated with the viewing process, where an audience is going to take a look at the final result of whatever it is that you produce. And that can be in terms of a video display, could be motion picture display. I'm not sure what other displays there are, but I'm sure that there are others. So, at some point or another in the history of imaging, people got together and said, well, they figured out, well, I'm thinking backwards from the figuring out of how the process of recording objects in motion and displaying them, yeah, it goes back to the Greeks, maybe even earlier. What they realized is that the eye has some difficulty interpreting fast-moving objects as they happen in front of the eye. So if you took a frame like this, and in it you can imagine that there is an object like so, and then in another frame, the object is over here, and it's over here, and it's over here, and it's over here. As long as there's a reasonable number of these, and they're quickly changing in position across the field, our eyes tend to interpret this as a steady movement from one side to the other. Before photography, it must have been going back to the Greeks, this process, even though they didn't have cameras, this process was understood. And one way to think about this is you might have a bunch of frames like this, and now you want to see them in quick succession. You say, well, how do I do that? What they did, or one of the methods that was used, essentially for animation, was to take a drum and you could spin. And here you put a picture, and another picture, another picture, and another picture, and so on. And another one. And in between them, you put a slot that you could see through. So over here there would be a slot, and from this slot you could see that picture. Okay? And and then when the next one came around, you saw the next picture from the next slot over here, if it's turning this way. Came here, then you saw the next one, and when that one got here, you see the next one, and so on. So sequentially, you got to see all the images inside of the box, inside of the drum. And how do I relate this to the Greeks? Well, they gave it a name. This is one way of doing it. Now, sure, your action can't last a long time. Okay? How long it takes this drum to turn around. But it was kind of a novelty type of a thing. And you can see these at the Eastman House if you go visit the museum, with all kinds of drawings, essentially they're animated sequences. But you could replace these with photographs too, and then it would still be animated, but it would be photographs instead of drawings. So eventually, it was Edison and Eastman got together. When would you think? When might you think that they got together? Roughly.
1920.
1920. Yeah, but I think you could probably go earlier. Because I think that there are, and that's when movies got started, right? think in the 20s, movies were fairly well established already. But anyway, what they said is, we're going to present these pictures sequentially to the eye by putting them in a projector, a slide projector, a projector. So we had an image over here, a light bulb behind it, a lens out here, and this forms an image on a screen. And what they developed was a means for replacing this image quickly. Anyway, it would be one after the other in the gate of this projector. So they were duplicating what this was, except now they had, because Eastman came up with cellulose nitrate on which there were the images were impressed, and they devised a mechanism for advancing the images in the projector. Well, at the same time as the projection system was being developed, or the fact that you had the means for projecting, cameras were developed parallel to that, because they also would be equipped with means for transporting the film inside of them, one piece at a time. And at that time, standards started to be developed for how projectors were going, particularly how projectors were going to record or project images. And the standard simply has to do with how fast are you going to show them. I think the earliest ones were something like, watch this. If I say about, I could say 10, and it was anywhere between 8 and 14 or something, right? About 10 pictures every second. The field was not that sophisticated, but this led to a noticeable change in brightness of the screen as the sequence of images was projected. So that change in brightness of the screen eventually was called what? Flicker. Yeah. You just mentioned flicker. That's right, flicker. Now to eliminate that, eventually people realized that what you had to do is change these images more quickly. So motion picture standards eventually went to 24 pictures per second. That was increased just a little bit to 30 pictures per second later on, and video runs at 30 pictures per second, as we talked about. And so then they, in order to view a scene that's projected in the same time frame as the time frame it took to project it, you had to make the pictures at the same rate as they were being projected. Just like in the audio system, you have a turntable, you saw the turntables. If you spin them at the wrong rate, the sound quality is not what it's supposed to be. Same with the... So, by way of a technical aside, this process of transporting images, even at 30 pictures per second, flicker, some people will notice it. And what it does, it causes a headache. So the projection systems and the cameras actually work essentially the same way. Inside of them, they have a rotating disc. And the disc has an opening in it. Like so. And over here would be the gate where the images are placed. And so as this disc rotates, for some time, there is light that is able to pass. Then the other part of the disc is in front of it and it covers it up. So during this time, the time that it takes this disc to turn from here to here, that's the time that you have available to advance the film, to put another piece of film in the gate. So you could imagine, well, let's say that we make the opening here 180 degrees. Okay? And some of them are that way. And if you're projecting at, let's pick 24 because that's an old-fashioned standard. And In that case, it takes this whole thing 1/24th of a second to make one turn, right? During half the time, light goes through, the other half, no light goes through. So that's 1/48th, and plus 1/48th, 1/24th. So you have a 48th of a second, roughly 50th of a second, to put a new piece of film in. Well, there are mechanical problems trying to do this more quickly than that. So, but you would like to eliminate flicker. So what do? Anybody know? You take this disc. I should have just left it there. And see if I can do this. So now you have something like this in front of the gate. Okay? So this still turns in the 24th of a second. But in that 24th of a second, it flashes the image 3 times on the screen. And now what you have, in order to move the film, is only that much, which it would be, well, this would be a third, right? That's another third, that's another third. And a third of a 24th. Is, and actually it would be that would be from here to here, right? And so this is a 1/6 of a 24th, which would be roughly, what, 120th of a second? You gotta be pretty quick. Did I do my math wrong? If this is a third of a 24th is 20, well, it's like a 60th, isn't it?
It's a 72nd.
Oh, okay, yeah, well, you're doing it exactly, right? 3 times 24. Okay. So, if this is half of it, in that case, we're talking about 144th of a second, right? It's not a long time. But anyway, by going like this, or with just 2, either way, what you're doing is you're increasing the flashing frequency on the screen, which makes flicker less apparent. You're still, you're still changing the image for every turn, but flashing it 3 times or 2 times. So ultimately, though, what happens is that you have to match in order to perceive the time on the screen with the time in reality. You have to match those 2. But the interesting thing is that you're going to unmatch them and then exploit the result. This concept of exploiting the result can be analyzed or can be discussed, I guess, from many points of view. But ultimately, or one of them is that just like in microscopy, just like in photogrammetry and so on, you express the result in terms of how much you magnify something. In microscopy, it's kind of easy to see that what you're going to do is magnify. It's starting very small and you end up with something very big. But in regular photography, you don't magnify. If I take this camera and I make a picture of you all over there, I'm not magnifying, right? What am I doing? Reducing, right? However, I could still talk about the images that I make as magnification, but what would the expression of magnification have to be? Or what would it be if I say, well, I wanted you to tell me what the camera's doing in terms of image to subject side. But I want magnification. Negative or a fraction, a fractional expression, right? So in the camera it'll be a half or a quarter or a hundredth, right? Whereas in a microscope things will be 100 times and so on. So, but you can always talk magnification if you want. Just got to realize that when your subject is bigger than your image, in that case you're talking about a fractional magnification. So one way to express the relationship in time between projected images and images that were recorded is to talk about time magnification. And how do we figure out what time magnification is? Well, it's going to be a relationship between the rate at which images are made and the rate at which they're projected. Now, I don't know if what I'm going to put on the board here is the right relationship, but I can test it. So may not want to hurry up on it. We'll take projection. Let's talk about rate. And then we take capture rate. So this means how many pictures per second are being made. So our projection rate is going to be our standard, and 24 pictures per second. And I'm going to find how that relates to our capture rate. Now, for capture rate, it's going to give us a time magnification of 1, which means that the time on the screen and the time for real are the same. Well, capture rate will also be 24 pictures per second. This is, as I call it, a falling off a log relationship. However, it doesn't help you. It doesn't help you for situations that are different than when they match. Because we could put these two upside down, right? And we'll still get a 1. We don't want a 1. Okay? We want to magnify time. In the time-lapse world, it's going to have to be a fractional magnification because we take a time which is very long and we're going to shorten it. In the high-speed realm, it's going to be a whole number. We're going to take a little time and make it bigger. So suppose that our capture rate is, we make 48 pictures, but then 48 pictures in 1 second, but then we show them at 24 pictures per second. In that case, let's see. Actually, I want to go there. That would be okay. If we did that, I went into the realm of high-speed work by making the capture rate faster than the projection rate, right? And yeah, but I don't want to abandon this mistaken path that I take. So I could change this to 48. So I photograph faster than I project. Now, actually that will work because, no, it won't. Because over here, this will end up to be a half, right? And in fact, it'll take us 2 seconds on the screen to see something that lasted only 1 second for real, right? I think so.
Yes.
Yes?
Yes.
Yes. So this relationship is wrong. Because this number should be a 2, not a half. So what do we do exactly? Remember I said, we can test logically whether we did the right thing or not. So we just do this. Great. And now we can put a 48 over here. And put the 48 over there. Now the time magnification is 2. Oh, 2? Yeah, something is wrong. My logic must be wrong here. That's John Ott is influencing me. Now let's see.
Didn't it make sense the first time?
I think I was right the first time.
You said that with time lapse you want fractional magnification.
Yeah, so we did get a half, didn't we? And,
Yeah.
and,
Yeah, but that was for high speed. Oh yeah, so this way would be,
This way would be high speed.
this way would be high speed.
gives you whole numbers.
Yeah. So yeah, talk to me, because I'm quite likely to make mistakes. So we go to here, and our capture rate. Yeah, I have a problem with this. This is not good.
I think it is capture over protection.
Okay, great. We have
Well, do you want the,
we have two sides to the story
It
here.
doesn't matter if it's high speed or time lapse, it's gonna be the same. It's capture rate.
with this, the 1/2 is denoting a compression. You're making it smaller. Right?
You're taking a long time and making it small.
Right.
You're multiplying the capture rate
2 seconds
by
divided by
a half.
1 second.
2 seconds. If you capture rate, suppose you photograph for a second in either case, right? Capture rate is 48 a second. You get 48 pictures,
They show 24 frames per second.
but you
We'll
show
make it
24
2
pictures per second.
It's gonna take 2 seconds.
So it's going to take 2 seconds.
Right.
Right? So our time, then our
Your result is bigger than your initial.
So that's high speed.
yeah, because you watch it over 2 seconds instead of the real thing that was 1 second. Right?
If your capture rate is slower, you're always doing time lapse. The capture rate is smaller than the projection rate because you're showing the same frame multiple times to keep the same frame rate.
But okay, so supposing that we change this to 12 pictures per second.
Right. Then you get time magnification of 2. Now it's time lapse because it takes 1 second to show each frame twice from the capture rate. Each frame has to flash twice before it moves on to the next one. Or you can show them all in half a second.
I was gonna say, it turns a 1 second duration event into a 1/2 second.
Right.
Right.
So that's time lapse.
You get 12 in 1 second, but you're projecting a 24, so now the time is half of the real time.
Yeah.
Right? But the thing is, if you do this,
It's 2.
time magnification is 2, and that is incorrect.
Okay.
Right.
Then it's capture rate over projection rate instead of
So,
projection rate over capture rate.
which is what we
Yes.
did, right?
Yes.
Right, so this time, because we're talking about fractional magnification, so it's like reducing by a factor of 2. Oh, but see, it's not a total loss. The point is, so to speak, is, you know, we're not stupid. We can figure this out. The gut says, well, this is how it's supposed to work. And so now we put our 12 up here, put the 24 down here, and we end up with a time magnification of a half. That means time on the screen is half of what it is for real. And this relationship holds, whether it's time-lapse or whether it's high-speed photography. So, but we're going to deal with time-lapse photography. Now, by the way, some of you, there's some of you are biomed, and there is some guy here who's also very good in the time-lapse field. And his name is, what's his name? he's a mini John Ock. That's all right. So you can determine what time magnification is a number of ways. Or time magnification can be used as a method for determining something which is kind of at the heart of either high speed or time lapse photography. And that is, I understand that in order to make a sequence of photographs, I will fire the camera every so often. Whether it's a film camera or whether it's a digital camera, it doesn't really matter. The question is, how often should it be? What should be the time between pictures? That is, and again, John Ott mentioned this sort of at the very beginning of the book. Do I photograph every second? Do I photograph every minute? It turns out that the determination for what the time between frames should be is really up to you. And you need to consider a number of things that are then going to influence what the time between pictures should be. In a way, you become your own customer, or you have a customer that says, well, I want a day, okay, reproduced in 1 minute. That can give you what the time magnification is, or it'll tell you what the time between frames is if you know the number of frames that you're going to be exposing. Well, let's take a sort of not a hypothetical, but an assumed situation. It helps, from my point of view, to first of all determine how long you want the event to last on the screen. Do you want it on the screen for 10 minutes? Do you want it on the screen for a minute? Do you want it on the screen for a second? Because if you know that, okay, total frames, they're going to be equal to the real time times (24). I could put picture per second over there, but I'm very poor with units and I get all mixed up. So I just put 24. What this would mean is your event is 1 second long, okay? And you're going to be projecting at 24 pictures per second. Well, you need 24 pictures, so 1 second times 24. Right? If your on-screen time, well, I guess it's total frames is not that. It's on screen. I think I said that, and then I wrote real time. This will tell you how many frames you need. So you say, well, I want this scene to be reproduced over, I don't know, the easy thing to do is to say 240, let's say 100 seconds. It's at, what about, a minute and a half? Is that right?
A little more. Minute 40 seconds.
Yeah. So times 24. That's 2,400 frames. The projector's running 24 pictures per second. You're running for 100 seconds. You projected 2,400 frames. And then you say, well, what's my event time? I don't know. An hour? Okay, so let's see, how many seconds are there an hour? Anybody know? 3,600 seconds. And in that length of time, I have to expose 2,400 frames, right? that tells me that it's 1.5 seconds, right? Between frames. Did I do that right? 1.5 times 24 is 36?
Yeah. Here, yeah.
There, two? Yeah?
That's right. 1.5 seconds per frame, yeah.
Yes, well, yeah. It's interesting because sometimes questions come at you as real time between frames, and other times they come at you as a rate.
Right.
So thinking about 1.5 seconds per frame is kind of weird because we're more used to small times between frames. I say, oh, 3 seconds per frame. Well, it's 3 seconds between frames. And each frame also gets exposed, you know, it takes a fraction of that to expose the sensor. So anyway, at the end of this process, if you do this every 1.5 seconds, in that case you will accumulate the right number of frames and then you project them back and they'll last the right amount of time. And your customer will be happy, whether your customer is somebody else or whether it's you. So I had to do this partially. I'm kind of at a loss right here because I'm missing a couple pieces of equipment, and you'll get to see what they are. But the reason that they're missing is because they're now tied up in a time-lapse project that I started over the weekend. And it's the building, it's the photography of the building that's going up over someplace. Yeah, it's over that way. So the camera system that I kind of kludged together is tied up over there. And but I have to do this also. It's a building in the process of going up, and it's going to take like 3 months. Well, I could run the camera at 24 pictures per second for 3 months. Right? That would generate an awful lot of pictures. And then I would say, well, but if I use all of those photographs and project them at 24 pictures per second, it'll take me 3 months to show them. Well, that's no good. I want it in a shorter time. So what do? I get a gazillion pictures. Well, I eliminate every other one. I don't need all of them. I take every other one. So now instead of taking me 3 months, it'll take me a month and a half to show. Right? That's the logic behind it. So, okay, well, how about if I eliminate, another one, half of what I have? Well, now it'll take you like whatever, 3/4 of a month, and it's less and less and less and less, until you get to the point where you say, oh, well, that's about right. I'd like to see it maybe for 10 minutes. So in this particular example, I normally don't have anything like that, but this one, it turns out I didn't make a decision based on 3-month period, but I guess I went rather on a gut feeling type thing. Said, okay, on a day I have 24 hours. If I take a picture every hour, I could do that. In this case, every day I'll collect 24 pictures, which is equal to 1 second, right, on a screen, running at 24 pictures a second. The thing about the 24 pictures per second is that if we have kind of the right conditions, there's 12 hours of daylight and 12 hours of nighttime. So half my pictures are nighttime pictures. I don't want that. So I said, well, I want more pictures than 12, okay, because that'll be just be a half a second kind of glimpse for every day. And I said, okay, well, that's no good. So then just kind of thinking about this, I said, well, I think what I'd like to do is to go for pictures per hour. And what was the logic behind choosing that? Well, if I do that for the 24 hour, 1 hour, I have 4 pictures. For 24 hours, I have what? 48 times 2, right? 96? Oh, yeah, and the neat thing about the 96 was that it's close to 100, and you know, that's a nice number to work with. So I said, okay, 96, and out of these, however, half of them are no good, right? But I have 48. Well, now that gives me 2 seconds per day.
So the course of a month is.
Which
6
is,
months.
yeah,
About 6 months per month.
which starts to kind of become human. And if you don't like that, now you can start to throw away half of them and make it faster. But you're not overly collecting. Okay? So the camera is running at about 15 minutes between photographs. The problem is the system is a homemade one and it's failing. So I gotta figure that out. But you have other kind of concerns, so to speak, besides determining what the time between frames is going to be, which you could approach from saying, well, your customer says, well, you ask the customer, what would you like the time magnification to be? And if you do that, you'll be looked at with blank eyes. Time magnification? What's that? You got to explain to them what it is. But for somebody who knows, you can say, well, you know, I want to magnify time to a factor of a half, or a quarter, or an eighth, or a tenth. Okay. And then time magnification allows you to figure out what the time between pictures as they're being made is going to be. Or you can take the gut feeling, of course, the way I do. But besides the fact that you need to put the time between photographs, you also need to worry about, well, you could figure at the end of 3 months, well, how many pictures would that be? I don't know. Well, it's 100 a day, right? So it's 3,000 a month. So it's 9,000 total pictures. Well, are they going to fit, if it's a movie camera, are they going to fit on the roll of film that you have? Or are they going to fit on a memory card? It may be a concern that they fit. Why is it a concern that they fit? Because anytime you touch a movie camera or a time-lapse camera, the chances of jarring it just a little bit increase. I mean, typically, you know, the advice is clamp it down, secure it down as hard as you can. And but the reality is, you touch it, you know, it just moves a very small amount, and that kind of destroys the neatness of a good time-lapse photograph. On the other hand, if you don't care, like I don't, you just touch the camera and you change the card. You know? And I didn't do this, but you might want to do this. If it's a film camera, in that case, it's a camera like this. You got this roll of film, and this holds 100 feet. 100 feet of motion picture film. Yeah, the people in film video still use film cameras, so it's not too far-fetched to talk about them. These are 40 frames per foot. So, in 100 frames, you got 4,000 images.
2¼ rolls.
Yeah, yeah, but the thing is that at the end of 4,000 pictures, you have to unload the camera and put a new roll of film in. Well, you're doing major manipulation of your equipment. Okay, and so you better be very certain that the camera is not going to move if you don't want to see that little jump between images. In a digital realm, well, the same holds true. you want to find out, well, how many images can I put onto the memory card or into memory without exhausting it? The truth is, I didn't do that. And I'm not exactly sure how it would work. Somebody criticized me for this, but I said, well, you know, suppose each frame takes 1 meg. Okay? Oh, you take a look at your card. And it says, you know, 1 gigabyte. So this is, let's see, from here you go to 100, right? That's the next, oh no, first you go to 10, but then you go to 100, and then you go to 1,000. 1,000 megabytes is 1 gigabyte, is that right?
Yep.
Oh, approximately, yeah. Yeah, I made a statement on the web someplace, and well, you just divide one by the other, and it turns out it's not quite right. Somebody chastised me. No. Yeah.
Manufacturers, 1,000.
Right.
Yeah.
Big deal. So, but that's the thought process. You know, you say, well, how much can I hold? How big are the pictures? How many can I put on there? Just like you would with film. And
How long is the battery gonna last too?
that's a good point too on these cameras as well.
Pretty sure.
They have,
the battery
while they hold 100 feet of film, in this mode, the camera operates in a spring. So you wind up the spring. Well, that only moves about 15 feet of film. So that means you got to wind the camera 6 times before you run out of film.
For one roll.
For one roll, right. So you got to think about that too. But the cameras can be equipped with electric motors, either DC or AC powered. For time lapse, you really would like the AC ones because you don't run out of power. But if you're out in the field someplace, well, now you're going to have batteries. And you might want to think, well, how much energy does the camera use compared to the amount of battery power that I have? Well, the batteries last. So it's a matter, again, of figuring out what the equipment is that you have with what the requirements are. There was something else that you mentioned that I was going to elaborate on. Yeah, I forget what it was. Oh, the question was about batteries, right? So, the camera that I'm using is my simple Canon digital, the original route. It takes a little battery. Well, that's not going to last long, because you got to leave it. Well, let me put it this way: if the time between pictures weren't very long, well, there are a couple other things that happen. In that case, you could activate the camera like every minute. Okay. The problem is that the camera doesn't like to be turned off for more than a minute, and it turns itself off. And once it's off, boom, you got to be there to turn it on again for the next shot. So you got to photograph faster than the minimum time or the maximum time that the camera allows you for it to stay on. Well, 15 minutes is not what the camera is designed for. However, it does have the provision of disabling that mode and staying on all the time. Well, if you stay on all the time with that battery, it'll only last you maybe an hour, and then your battery's shot. That's no good.
A lot of batteries.
Yeah, but you got to change them too. And so I said no. Like I said, you want AC power if possible. So I wrote to China and got myself a $15 AC adapter. The Canon one is $150. China is good for that. Or India. And now you just plug it in the wall and you can leave the camera on all the time. And it doesn't catch up. So I do recommend it. Get AC power. And John Ott, all his cameras with AC power. So there are a number of concerns that you have as you design and set up a system. And ultimately, the device, or when you go to make the photograph, you say, well, I'm stymied. I know that the pictures have to be made once every second, or that's what I want to do. How do I do that? Well, you can here's a prime example. How do you start? How does it just about anybody used to start, and even probably today? Well, you get your camera, you get your subject over there, and you know, you go, you wait a while, make another one, you wait a while, make another one, make another one, make another one. So now you're sitting there with the camera pushing the button every so often. Does that work? Yes, it works fine. You gotta be pretty patient to record 1,000 pictures, right? But it works. And so that's the first step, saying, I can do this. I just need patience. However, the next step is to automate that process. Use some kind of a device that is going to time the time between shots. And that is called an intervalometer. Interval meter. Intervalometer. Measures intervals. An intervalometer is can be either mechanical or they can be electrical. I like the mechanical ones because you can see what's happening. The electrical ones are nicer, but and sometimes intervalometers are built right into your camera. I should maybe confess right now that I don't have, the lab here doesn't have a time-lapse camera. However, there are some in the cage. Which ones? I don't know. That's why there's an instruction manual. I think the Olympus cameras have it, or some of them do. But anyway, I don't know. I can't tell you, which brand or whatever. There are so many of them. And sometimes it's a very simple camera that has an intervalometer in it. Sometimes it's a more expensive, or more sophisticated. But they have a built-in timing device. Those are neat. Often they are somewhat limited in terms of range. Meaning they'll fire a camera every minute, but that's the longest. And if you want longer than that, then typically you'll have some kind of a specialized or more sophisticated timing device. And this is a good time to take a break. You guys have been sitting for an hour. Oh, before you get up, are there any questions? It's a good time to ask because there won't be any because you all want to get up. All right. See you in about 10 minutes. Oh, there is a reprint, what some people call handouts. I don't like to call them handouts. That you can take now. It's some short notes on high speed and time-lapse photography. Take them now or whatever.
So I was sailing a boat.
I didn't know that you were a sailor.
You didn't?
No. I would have asked you too.
I was already sailing this week.